All right, so just picking up where we left off, we did talk about what happens when you add h or k. Now I want to look at what happens when I multiply by a at the beginning. So we used yellow. Let's use gray is fine. What happens if I multiply a at the beginning? So you can see here I have 2 sine x. Right, so I started with sine x, now it's 2 sine x. Alright, so let's just get right into it. The blue will do, let's see, sine x in green, 2 sine x in blue. We already have sine x. We said that it was sine of negative pi is 0, sine of 0 is 0, sine of pi is 0, and sine of 2 pi is 0. So you can save a little time there. And then let me just whoa, really screwed that one up. Okay, so you're looking at that, which again we've already seen up here, so I just copying that down here. All right, but 2 sine x, little bit different. When I graph these, I'm going to go sine, actually, let me go y equals sine of x. Okay, graph, we've seen this graph. When I go 2 sine x and I hit graph, you can see it's a little bit different. All right. Now I'm going to tell you right now that the data table isn't going to do this justice. We kind of have to add a little bit more onto the data table. But if I look at negative pi, 0, pi, 2 pi, let me plug those in and see. So we'll go 2 sine of negative pi. Enter. All right, I still get 0. 2 sine of pi. I still get 0. Okay, so I'm still going to get a 0 here. So we can go quickly fill these out. So quickly fill these out. 0, 0, 0, 0. 0, 0, 0, 0. But look what happened. Look what happened on the other parts of this graph. So like here and here, there's a difference there. Here's the 0, here's the 0, here's the 0, here's the 0. But look at my peaks and my valleys are different from one another. So let's look at a different example. We'll go sine of pi over 2, for instance. So sine of pi over 2 is 1. 2 sine pi over 2 is 2. Alright, so multiplying that 2 in front, I wonder what happened here. So let's try another one. Sine of, we can just do pi over 4. That's fine. Actually, yeah, pi over 4. That'll work. Okay, so you get 0.707. Okay, 2 sine pi over 4. You get 1.414. Okay, if you notice, 1.414 is double 0.707. So anytime I'm outside of these, 4 points, I'm actually doubling. We said pi over 2. Here it's 1, but in my blue function it's 2. What else did we do? We did pi over 4, which is right here. It's that, but really it's up there. Right at 1.7. Alright, so this is what happens. Negative 3 pi over 2 is there, so it should be there. Same thing here. So it should be negative 1, so it should be there. So let me draw this now. Alright, so there's a little bit of a difference there. Let's think about what this is. Maybe maybe you're putting it together from previous transformations, all of the previous transformations. But here's what happens. What happens when I multiply a at the beginning? I have a vertical stretch or shrink. Okay, a vertical stretch or shrink. In this case, it's 2, so you have a stretch, right? It's getting larger. It's obviously you have space here, right? You're stretching out. So we have this: if a is greater than 1, you have a stretch. If a is between 0 and 1, so a fraction, you have a shrink. Okay. Let's put it all together. Let's talk about everything. We just talked about a. So where was this? This was a vertical stretch or shrink. Okay, and then obviously that's in there as well. B we didn't talk about, but let me just give it to you. B is what we call a horizontal stretch or shrink. Let me show you one. We don't have to go through it all, but let me show you one because it's actually kind of cool. If I did... So here's sine of x. Down here I'm going to do sine of 2x. So notice it is now on the inside. That 2 is on the inside. Okay, here's sine of x in blue. Here's sine of 2x in red. You could really kick this to the extreme too. You can do 10x. Here's sine of x. Here's sine of 10x. Kind of fun, you could fool with that. But what do you notice? It's either cramming together or it's spreading out. So what you have is a vertical, or you have a horizontal stretch or shrink. Which we've kind of talked about before on other things. We have a horizontal stretch or shrink. If b is greater than 1, you have a horizontal shrink. Like an accordion almost, if you guys know what an accordion is. If b is between 0 and 1, you have a horizontal stretch. It's going to stretch out. You're going to get more space in between your periods. Okay, H, we've talked about H before up here, which was in yellow. What happens? You translate left to right H units. So H, this was a horizontal translation. H units, and you gotta think opposite here. And then, of course, the last one that we did, K on the outside. What happened? I did the vertical translation. I went up or down. So, we have a vertical translation. K units. So this would be up or down. Alright, these coincide with every single transformation that we've talked about this year. So if you know those, you should know these as well. Whether it's sine, cosine, or tangent, all of these A, B, H, and K stay consistent. Okay, so if you know one of them, you know all of them. And then ask yourself, does this coincide with your predictions from the past 2 lessons? What made you make those predictions? And how does that how do all of these, is something I want you to think about, how do all of these affect the period, the amplitude, the midline? Think about that as you go through this. Think about that as you think about that last question. Alright, seniors, thank you very much. Hopefully I hear from you guys, the rest of you guys. We still got a few more weeks, so let's keep going.